So for Algebra 1, today we're going to go over lesson 2.4, which is solving equations with variables on both sides. When we're solving equations with variables on both sides, we basically have two things that we want to do. We want to get the variables on one side, the constants on the other, where constants are just numbers, right? Once we have it separated, we should be able to solve it with a one-step or a two-step equation, okay? So basically, we want to change it into a form where we know how to solve it, right? So here I have a problem, right? Variables on both sides. Have we had variables on both sides yet? No, not in here. So what I want to do is I want to put both variables together, okay? Now, Adrian back there said minus 2x. Okay. And Haley wants to minus 2. Oops. Minus 2. Who's right and who's wrong? So I'm hearing Haley's right. Adrian's right. I'm hearing, man, we got a split between classroom, okay? Is there a difference? Did either one of them break a math rule? No, neither one did, so they can both be right, okay? So we'll solve Haley's over here, and then we'll solve Adrian's over there, and we'll solve Adrian's in blue. Okay? So with Adrian's, he wanted to minus 2x first. Minus 2x, minus 2x. We get 3x plus 2 is equal to 14. Okay? Then we would minus 2. Right now it's a two-step problem, right? Is that what you're going to ask?
But how are we supposed to see it if we go on the line to look at your problem? Is the problem maybe that you?
What?
You're recording your voice.
Yeah.
Yeah, but how are we supposed to know what to do when you're just telling us the words? There's supposed to be a problem right now.
Like you'll see the screen. Yeah. All right. So here we'll minus 2, minus 2. We get 3x is equal to 12. Now it's a one step. Divide by 3, divide by 3. We get x is 4. Okay. Let's go over here to Haley's way, which she wanted to minus 2 first, right? Minus 2, minus 2. 5x is equal to 2x plus 12. Then what does she need to do? Minus 2x. Minus 2x. She gets 3x equals 12. Now, do you see how that right now she got the same thing as Adrian did at one point? Yeah, and then divide by 3, and we get x is 4. So it does not matter, okay? So what I would recommend is finding a way that you feel comfortable with, and just do that one every time, okay? Whether it's move the variable first or move the number first, okay? Where there is one thing I want to point out that they both did, which is good, okay? Adrian said to move 2x. Is 2x bigger or smaller than 5x? Smaller. Haley wanted to move 2. Is 2 bigger or smaller than 14? Smaller, okay? You should always try to move the smaller number over to the bigger side, okay? The smaller number over to the bigger side. What that'll do, it'll keep you from getting as many negative signs, okay? If you forgot and took a bigger number and moved it, would it be wrong? No, because you'll get the right answer at the end. But would you rather solve a problem with positive signs or a problem with negative signs? Positive is just a little bit easier, right? So if you get in the habit of moving the smaller number, you're going to have less negative signs, which gives you less headaches. Okay, here we have a graphic designer. He can make a web page in an hour and a half. He's thinking about getting new software, and the new software would cut that time from an hour and a half to 1.25 hours. But it takes 8 hours to learn the new software. How many pages, not ages, how many web pages would the designer have to make in order to save time using the new software, okay? So on this one, we need to come up with an equation, all right? We need to decide what things are going to be equal to each other, right? What do we want to set equal to each other, all right? What do we want to know what's equal to each other? I want you guys just to look at, not the math words quite yet, but look, what do we want to know in this? How many web pages? So web pages from what? Which software? We're talking about two in here. So we have new software, and that should equal what? So if we put 1.25 over here, we're not going to talk about old software at all, are we? So we want to know, when is new software going to be equal to old software? Okay, I want to know when those are going to be equal. All right. Let's start with new software. How long will it take them to make web pages with the new software? Let's ask Ryan. 1.25 hours. That's not everything. What else is there? What's that, Vlad? And he has to learn it for 8 hours. Okay, so he has that extra education time, right? His old software takes how long to make a web page, Colton? An hour and a half. Does he need to learn how to use the old software? No, he already knows how to use it, right? So there's no pluses in there. Now this is an equation with variables on each side. We can solve it, right? So what do we want to do? What's our goal when we have variables on both sides? Put the variables on one side, right? Right, we want to combine those variables. Which variable do you guys want to move? 1.25. Why 1.25? Why don't I want to move point? It's a smaller number, right? Less negative signs. We get 8 is equal to 0.25h. Now we can divide by 0.25. Right now it's just a one step. Divide by 0.25. Divide by 0.25. H is, no, not 2. Not 4. What is it? 32. All right? So it should take 32. I used H, which was kind of a bad variable, because of, what are we measuring? This isn't hours, is it? Yeah, pages, right? How many pages did we make? So I probably should have used page or P or something instead of H. But that's 32 web pages. So he has to make 32 web pages for them to be the same, right? Same amount of time. If he makes less than 32, the old software will be quicker. If he makes more than 32, the new software will be quicker. Okay. So knowing this, right, if we go look back at the warm-up, could we make an equation for this one? Yes. What do we want to set equal to each other, right? In the last one, we wanted old software and new software to be equal to each other. What do we want? I'll give Chase a shot. So we want A equal to B, okay? So that's Isaac, all right? What's the population of town A? How can we find that? Mm-hmm. So you just want to keep on adding the number until found. So you want to make a chart like we did before, right? We want to try to do it a different way with an equation, right? Now, we need a variable. What's the variable in here going to be? T for what? How about we could do Y for year, T for time, right? Something like that. I like Y. So my variable is going to be Y for year. Because, well, how you can tell what the variable is by looking at that last sentence where they're going to ask a question. It says, how long, right? So what part do I not know? How long it takes, right? So we'll say Y is year. Right. For town A, we have 3225 and 100. Which one of those two numbers belongs with my variable? 100. Why 100? How do we know? Yeah, it says per year, right? Per. Is that per matched with our variable? Yes. Per year, right? That's the key word that we're looking for. So now I know that I'm going to have 100 times y, because that 100 per year. Is that everything? What else do I need in there? Yeah. You need to add those two together, okay? All right, Chase, try to build me town B now. Y. Good. Now to solve this, what do we want to do? Minus 75, right? We want to put the variables together. Minus 75y. We get 3225 plus 25y is equal to 3300. All right. Now what? Minus the number, because we want the constants to be on the same side too. If I minus those two, I get 75. And then divide by 25. How many years did it take? How many did you guys find it took on your warm-up? 3. All right, so let's go forward. This one. A little bit uglier, right? So does anybody have any ideas what we should do first? Distribute. Vlad. Distribute. How many times am I going to have to distribute? Twice, right? Remember, with the parentheses, it means distribute. I'm going to say 2 times 5x, which is 2 times 1, which is? What operation goes there? Minus, the same one as that's up there. Equals 3 times x? 3 times 11? What operation? Good. Which variable do you want to move Elvis?
5x. No. 11.
We're looking here. You want to move the 33 first? It's all right, we can do that. All right. Now, we'll move the 33. Does it break any math rules? No. It is perfectly okay. But remember what I said about moving the bigger number. What is it going to give us? Yeah, it's going to give us more negatives than we would if we went the other way. Okay, so this is a good one. I'm just going to show you guys. It's going to deal with more negatives, and we're going to have to do something a little bit extra at the end. All right, so it makes it like one step longer. All right. So now if I have all the constants over here, I need to move my variables to the other side, right? So I need a minus 10x minus 10x. I get negative 35 is equal to negative 7x. See how there's two negatives in that one? If we went the other way, they'd both be positive numbers. Okay. Now, what do we have to divide by? Yeah, negative 7. I'm going to divide by negative 7, divide by negative 7. We get positive 5 is equal to x. So, let me ask again, can you move a bigger number or a bigger variable? You can. Will you get the same answer? You will. What's the difference going to be, though? Like more negative signs. It might give you an extra step, but as long as you don't break any rules, you can still do it. Okay? All right. Last one we're going to talk about are identities and no solutions. Okay? Identities and no solution. So I think probably what I'm going to do is I'm going to explain, or we're going to go through part A, and it's going to get a funny looking answer. It's going to look different than usual, and we'll decide whether that's going to be an identity or a no solution. Okay? So what do you guys want to do first on part A? Distribute. Okay? So I'm going to say that's 10x plus 12 is equal to, that's 10x. That's 12. What operation in between? Plus. What do you want to do next? Put the x's together. Okay? And what do you want to do? Which x do you want to move? We're going to move the one on the right, so we're going to say minus 10x minus 10x. Those cross out, but what happens over here? That's a little bit different, isn't it? Because we don't have any x's anymore, do we? All we have is 12 is equal to 12. When is 12 equal to 12? All time. It's 12 is equal to 12 in the morning. 12 is equal to 12 in the afternoon. 12 is going to be equal to 12 on Saturday. 12 will equal to 12 at 12 o'clock. This will always happen. Now, if you guys had to guess, would you say that's an identity, or would you say that's a no solution? Identity. Okay, that means no matter what you put in for x, you will always get an answer, a right answer.
So that could be a complete answer.
When you get here, your complete answer is going to be identity. Okay? What identity tells you is that it does not matter what x is, you will get a right answer. All right? Does not matter. Jesus, give me an x. Give me a number. 15. If I take out x and put in 15, these two sides will equal each other. Does that happen with most equations? Most equations, you can plug in only one number, and it will give you a right answer. Right? So 10 times 15 is 150, plus 12 is equal to 2 times, 5 times 15? 75, I think. Plus 6. 150 plus 12 is 162. That's 2 times 75 plus 6 is 81. 162 is equal to 2 times 81 is 162. Are those equal? Yes. They are. Right? Does not matter what you plug in for x. We could do this all day. We'll always get two numbers that are equal. They might not be 162. That might be, 212 is equal to 212. 5,002 is equal to 5,002, but the two numbers will always be equal no matter what x you plug in. Okay, let's try this one down here. Okay. What do you want to do first, Michelle? So you want plus 3m. plus 3m plus 3m gives me 12m minus 4 is equal to 5 plus 12m. All right, Vlad. You could have combined them first, right? I could have said negative 3m plus 12m is what? 9, because this one's a negative. It's a negative sign in front. So you could have said that's 9m, and you could have done the problem from there. Are either way okay? Neither way breaks the math rule, so either way will get you a right answer. Okay? So again, right? Find the way that you like, right, and do it that way. Colton, what's my next step? You want plus 4. We get 12m is equal to 9 plus 12m. All right? Isaac, what's the next step? Minus 12m. Minus 12m. Those cross off. These cross off. Well, hey now. Is that what it's supposed to look like? What goes on the other side then? And then we crossed off all the m's. 0, right? We have nothing left on this left-hand side, right? In math, we have a number for nothing. It's called 0. When is 0 equal to 9? Never, right? This one has no soul, right? This will never happen. So no soul. What? Never happens, right? The only times this happens is between your test and my desk, and then it gets a big red line through it, right? Because that does not happen. Here's your homework. It's all about equations with variables on both sides.